Hello everyone. Today we're going to be talking about a new introduction to our asymmetric family, and we call that the Pru-Cove. You may be familiar with our MicroCove, which is here on the table to the right of me, but the Pru-Cove is following the trend of miniaturization and specifically with coves, as they tend to get smaller both in size and height, but also the distance between the cove and the ceiling gets to be even smaller. And so when we started this project, we asked ourselves, what can we do to affect that or to help that application? And we came up with two things. Obviously, one, it needs to be much smaller because we're going in places where usually only tape could fit. And then the second thing was because we're getting very close to these ceilings, the tape was only giving you a glow out of that, and maybe if you wanted to just articulate that cove, that was fine, but if you wanted to throw something into the space or even light the space from the cove, we needed something with a much better throw. And because we are now very tight to the ceiling, and by that I mean less than 12 inches, to throw light very far, we're going to have to work on creating something that's very close to a graze optic. And so the product itself, and this is the remote-driven version, as you can see, answers that question. The question was, how small can we make an asymmetric optic? And honestly, as you compare what we have come up with what we knew before and is current in our MicroCove, you'll see that obviously scale is significantly smaller. So we are down to effectively 1 inch tall by 1.5 inch wide. So to do what we wanted to do in terms of our optical development, it really took a different approach from our previous MicroCove, which is using a reflector system and simply a prismatic refractor in the front. And in this case, to shrink this down to the scale that we wanted to, we now are using 3 different optical components. So the first one is a TIR style optic, which is placed right on top of the chip, and it captures everything that comes immediately out of the chip. The front half is moved towards the main beam, or our main aiming angle. The second half of the chip is captured and then sent into the second part of the optic, which is a specular reflector, which grabs that from the back half of the chip and then throws that also into the main aiming angle. And then the third is a secondary prismatic refractor again, and its job is to clean up any color striations, and then also to throw light above and behind the optic itself, so that when you get into the cove, it's this area that you have to worry about. And so the second part that we're talking about, the light that's happening above and then behind in the back of the cove, become really important actually. And so that's what that third optic does, is to push light into the back, because if I have too much light going into the back, that becomes the brightest thing in your field of vision, and that's what draws your eye, and all of a sudden you have now what looks more like a floating ceiling effect. If it's not enough, it appears dim, or worse, even with shadows. And as you look into that cove, you'll notice that it was not filled well. And so the challenge with throwing light very far, almost like a grazer, is that typically the grazer is a unidirectional optic, and we don't worry about what's happening behind. And that's how we get such a tight beam. In this case, though, we have to get a really tight beam and to throw light back up into the cove. Otherwise, it just looks bad. So when we were creating this, we realized that you don't always want to throw light all the way across the ceiling. Sometimes I want to get out of the cove and just get out of the cove to light space. And so we have 2 different optics that we've created, and one of them is when we go with our remote only. I have, as you'll see on the polar plot, a 15-degree aiming angle from above the horizon. And as you look at that polar plot, you'll see that I come back towards the LED in a very flat approach, which is what allows us to give a very even or flat feeling to that surface that we're lighting. And the other is when I don't want to throw it all the way across the room and maybe even hit the other wall. we have our integral version. And with the integral version, you'll see that I have the driver body in front. And we've painted it black because we want to suck up some of the light that's happening here. But also, this is when I would be, and if you look at the polar plot now, I'm about 10 degrees higher than I was with the remote version. And this one will throw light out, especially if I have an angled ceiling or a little bit deeper space between the ceiling and the cove. This one will work a little bit nicer in that approach. Will give me more of a focal glow, if you will, if you're looking at the ceiling versus a very flat or evenly illuminated ceiling. And so the two optics are choices based on what your desire is and what the installation looks like. All right, so from the Cove perspective, we have a MicroCove, which has been really well received. It's won numerous awards. It does a fabulous job, honestly, pushing enough horsepower to light space off of the ceiling from the coves. The question is, why do I need to expand our offering if that product is so great? And it is, but the point is the MicroCove was really designed as a one-size-fits-all, optically, and which means I need more setback than today's coves are given. It really works best from 18 inches and beyond. The scale of the product itself is fairly robust in today's world for coves. Everything is getting smaller. Miniaturization is happening everywhere, and so the Pru-Cove is our answer to that. The Pru-Cove gets physically much smaller in the integral version as well as in the remote version. We can handle coves that are much more petite, but it also addresses the need for a tighter beam that throws light from a much shorter setback. So now we're talking in the definitely less than 18 inches, but less than 12, often down into the 6 and even 4-inch range now, where designers are still wanting to push light out of the cove, get it across the ceiling, light space, and the MicroCove is just not designed to do that kind of scale. And so the Pru-Cove answers that for us. In either version, we get that same approach. Okay, so when you talk about coves, there's really two kinds of coves that we deal with usually. One is the one we've been talking about already, and that is from the wall, looking out into the room, and we're lighting typically up the ceiling and bouncing that back down into the space, either as a soft glow or as the ambient light for the space. The other side, or the other option for coves, is at the perimeter as well, but we turn it around and we face the wall from some short distance. We aim up into the ceiling and bounce down from the ceiling down into the space, and it creates a nice glow. We're just simply articulating that intersection of the ceiling and the wall, and so we'll call that a floating ceiling effect. And we have products that do that. This technique has been around a long time. Our product is called our P59, and we call that a cove in a box because it comes prefabricated. So the cove itself is made out of sheet metal, and then the housing attaches to it, and you put the whole thing up, and you have it, there you go, cove in a box. The features about those kinds of products, though, is obviously you're limited in terms of your aperture choices. We currently make two, a 6-inch and a 9-inch, and in today's standards, sometimes that's a little big. But you also have some plenum height challenges sometimes, and so you can use those, but that sometimes is a challenge. And then when you choose those products, there is one feature about all of them, ours included, and that is it's a fixed optic. And so the LEDs sit and reside behind a fascia, a front fascia, which hides them from the viewer's viewing angle, and light up into the ceiling. But that front fascia creates a shadow point, and we have to be very cautious to aim that shadow exactly into the corner of the ceiling and the wall. So those are some challenges. The PCI, our Pru-Cove indirect product, which is this now, addresses those challenges in a little bit different way and gives you some more flexibility. So first of all, you don't have to use our cove in a box. You can build your own. And it can be any dimension, which is really nice in terms of aperture opening as well as ceiling heights. Because it's adjustable, we can aim away from that fascia. The fascia will typically reside below it. And then secondly, because we're using that, that top prismatic refractor on the outside of the fixture, it softens the beam. It gets rid of any potential striations. It allows us to fill that ceiling really soft and really nice. And so for maximum flexibility, for use with non-Cove in a box style products, our PCI really fits that bill really well. The Pru-Cove aiming is achieved by a notch on the end plate that aligns with a notch in the housing. And you'd use a screwdriver or your fingernail or something small to put it into the right notch. These notches have an indicator, an arrow on the end plate, which shows you the neutral position, which is the most forward aiming of the main beam. And they do come from the factory preset in that position. If you'd like to adjust them, you simply loosen the nuts on the end and you get adjustment of about 50 degrees. The aiming notches on the end plate are in 10-degree segments. The other thing that really doesn't happen often but can, and we want to enable it with this family, is now in that exact same application where instead of aiming up into the ceiling, now we want to peek over that front fascia, still be coplanar so that if you're underneath it you do not see it, but throw light down the wall in a graze effect. So if that wall happens to have a texture to it, which is the reason you would do this, we can create now some very strong interest with shadow and highlight coming from a fixture that's hidden. And there are not very many fixtures on the market that can do that part. And so the Pru-Cove graze is what we call that. And you can see it's adjustable here. We have a front fascia, or they may have a front fascia of multiple widths and heights, and it is adjustable to telescope out and look down, still remaining coplanar though. And so while the MicroCove is great at the things it does, the Pru-Cove expands our ability to do much more. So one of the things that our Pru-Cove offers that our MicroCove did not is the ability to create your own coves using our extrusions. And so for this family we wanted to do so, and we have. We've given you a traditional straight fascia extrusion, which is intended to have mud as well on this fascia as well as on the bottom. And then a now more common knife edge extrusion, which again is intended to be mudded here as well, and gives people this idea that it is a forever ceiling. And to do that, we needed two different sizes as well to accommodate both our integral as well as our remote optics. And these have been designed specifically for these, so they match exactly in size, both in height and width, and that allows for us to maintain our aiming angles and a perfect fit within the cove. So there are times when you are not making your own cove, but maybe you're relying on a prefabricated cove by a prefabricated ceiling like the Armstrong AXIOM. And in those instances, they make their own coves, and products that are designed to fit in those must comply with a couple of things. One, obviously, the dimensions of the cove. We can't be any higher. We must fit within. But they also have a key slot in their extrusion. And our fixtures also have to carry that same key slot, which allows them to sit perfectly aligned, to slide in and be in the perfect place. So as you look at our different versions, this key slot is right here on the bottom, and it fits perfectly with the Armstrong. And so whether that is a Armstrong where we're going from the wall to the ceiling in a traditional sense, or if we're more of the floating ceiling approach that we talked about before, those coves all have specific dimensions, and we have made our fixtures to match those dimensions so that we do not peak above, we are not bigger, it fits perfectly with all of the AXIOM ceilings. If you have more questions, please feel free to reach out to us via our website or your local agent.